How's it going, guys? And now we're going to start beginning graphing our objects and such. So first we're going to create a 3D scatter plot of our experimental data that we determined already, or that we calculated, I should say. So if you remember, when we go up to the top, we imported our plotly.subplots as make subplots, and our plotly.graph object is geo, and then we set our, how about plotly.dark, and we set our template to default, or deflat apparently, because I can't spell, so template, and that was supposed to be a default. Okay, so with those errors fixed to start off the bat, we can get into making our scatter plots. So the first thing we're going to do is we're going to create a subplot. So we're going to do fig, and we're just going to call it fig for figure. So fig equals np.subplot, or not np.subplot, but we're going to do fig underscore make underscore subplots. And then open and close bracket because we're just making one set of plots here. So I'm going to shift enter, and then that worked out well. So now we can actually add things to our scatter plot, or our plot I should say, because there's no scatter plot involved. But we're going to do fig.add underscore trace, and then we're going to say geo for graph object dot scatter, or geo scatter, and then 3D. And then what we're going to do here is we are going to add in all of our components. So we have our X component is going to be our Reynolds number. Our Y component is going to be our Schmidt number. And then our Z component is going to be our Sherwin number. Shift enter. How about go dot scatter. And then as you can see, we have this massive object because these things are huge. So what we're going to do actually is we are going to resize it and then change the mode to markers. So now we have that. Or is it mode? It's going to equal markers. And then we're going to set size, or I should say marker equals, or marker underscore size equals 3, and then we're going to set marker underscore color equal to sh to make it more colorful. Hopefully this works, and there we go, perfect. So as you can see here, we have a scatter plot of all of the experimental data that we calculated via our inputs over here from our random uniform data. And now what we want to do is actually add in a wire diagram in order, or should I say like a wireframe, in order to plot our equation that we calculated from when we determines the initial A, B, and C values from our linear regression due to our matrices. So what we're going to do here is we're going to add in some wireframes, or some what do you call them? We're going to add in some wire, a mesh grid. That was the word I was looking for. So we're going to do np.meshGrid, and then we're going to put in input our two arrays of our Sherwin number and our Schmidt number, or not our Schmidt number, our Reynolds number and our Schmidt number. So the first one we're going to input is our Schmidt number. So we had, we're going to linear space that so it's evenly spaced apart. So we're going to do np.linspace. And then what we're going to do is set our parameters. So we're going to start at 0.6 like before, and then our max will be 2.5. And then I want 25 total points. And we're going to do the same thing for our Reynolds number, except for we are actually going to use the 2,000 as our lower limit from before. And then we had 35,000 for our upper limit. And then we have 25 points. So Shift Enter, and as you can see here, we have a varying number of Schmidt numbers, and then we have a bunch of those, and those are all related to a array that contains our Reynolds numbers that stay constant throughout as the Schmidt number varies. And then so what we're going to do is call these our grids. So we're going to say that the first component of that is going to be our Schmidt grid. So we're going to have SC grid, and then we're going to have our Reynolds number grid, and they're going to set it equal to that into our mesh grid that we just created. All right. And now what we're going to do is create a wire, or a mesh grid, I should say, for our Sherwin number. So we're going to say SH grid is equal to, we're going to do the use our matrix that we created earlier through our linear regression of matrices, and we called that U. So we're going to actually, since our first component, if you recall, of our variable matrice was ln of A, so we're going to have np.exponent, and then we're going to take the exponent of the first component of our array, or our matrice, I should say. And what we're going to do then is multiply that by our Reynolds number in the grid. We're going to take that to the power of the second component of our matrice, and then we're going to multiply that by our Schmidt number, and we're going to take that to the third, or take that to the third component power, or the third component, to the power of the third component in our matrice, I'm sorry. And then should hit Shift Enter here. Oh, how would we do Schmidt grid? Alright, and now what we can do is we want to update and add that to our graph. So we can do, and so what we can do actually first is pair every value together to earn points, or to create like data points. And in order to do that, we can use a zip function that Python already has pre-built in it, and that will basically just combine all of our points in order to make a graph that we can actually place into our scatter plot, or our figure, I should say. So for I, J, and K in zip of, let's see, our X component is our grid, our Reynolds number grid. And then we have our Sherwin, or Schmidt number grid. And finally our Z component is our Sherwin number grid. Then we're gonna fig.add underscore trace. And we're going to do go.scatter and then 3D with our x equal I, our y equals to our j, and then our z equal to our k. And then we're going to set the mode equal to lines, and then set the line underscore color. We'll set that equal to gray. Oh. Scattered, oops, I meant scatter, and then 3D. Alright, so it worked, but it did not display, so only one thing to do when running into that. We're just going to call it. Alright, so you see there, we only have one side because we're only varying one element at the time. So if you want we have the horizontal, if you also want the other direction, we're just going to have to copy and paste the initial equation we wrote out, so this one right here. And then what we're going to do is we're going to have to just switch the Reynolds number and then the Schmidt number in order to switch which variable we are altering when displaying our data. So all we have to do basically is give this a nice little copy, move it down here, and then we're just going to have the Reynolds number first because we're going to vary that one. And then have the grid, Schmidt number grid. And then what we're going to do is we are going to take this, I'm just going to copy that real quick, delete, and then place it into there where it will stay constant for us for all of our varying Reynolds numbers. And then hopefully if we hit Shift Enter, nothing happened, but we can just call our figure, and there we go, we have a nice mesh grid. But I don't like this, all this jazz over here, and I'm not a fan of how everything's looking. So what we're going to do is we are going to actually we're going to update the look of our grid. So to do this, we just do fig.update, and then we're going to do layout, and then so what we're going to do is we're going to set the width equal to 800, the height equal to 800, and then we are going to, after the width and height, we are going to change the scene. So scene equals dict, and what dict does is basically just stores all the values into a dictionary and we're able to display it onto our graph. So we're going to do x-axis underscore title, and we're going to set that equal to Reynolds number with our y-axis underscore title, and then we're going to set that equal to our Schmidt number, and then for our z-axis underscore title, we're going to set it equal to our Sherman number. And then what else I'm going to do is I'm going to set the legend equals to false. And then that's just basically going to say that, or not legend, but show legend equal to false. And that'll just take away all of these trace marks that we have from our grid. And then there we go. Now we have our Schmidt number, our Reynolds number, and our Sherwin number. And then we have each individual data point that we use from our experimental calculations that we did, as well as our wire diagram, which represents the linear regression we did for the matrices, and our U matrix that we determined to be the coefficients and exponents of their respective values, which also relate to the Reynolds number that the book gave us. So we can see that when we have a situation where we have some kind of wooded wall with gas going up the middle, our dimensionless groups, and we can see the dimensionless groups and how those numbers affect our data. So I hope you guys learned something today, and I'll see you in the next video.